Hari Om. Hello everyone, I am Shrees. Welcome back to my channel. This video is of class 12 mathematics chapter 1 relations and functions part 3. So make sure that you have watched part 1 and part 2. So in this video we are going to study composition of two functions. So for that let us take three sets. Let x is equal to 1, 2, 3, 4 and let y is equal to 2, 4, 6, 8, 10 and z is equal to, okay, let z is equal to 4, 16, 36, 64, 100, okay, 121. So here we have taken three sets and let us define two functions. Let us define, first we will let us define the function f from x to y by f of x is equal to 2x, and let us define another function g from y to z by g of y is equal to y square. So here we have defined two functions f from x to y by f of x is equal to 2x and g from y to z by g of y is equal to y square. See here the elements of x are assigned uniquely to the elements of y and similarly elements of y assigned uniquely to the elements of z. That is, see here we have defined the function as f of x is equal to 2x and g of y is equal to y square. That is, image of 1 is equal to 2, image of 2 is 4, image of 3 is 6, image of 4 is 8, right? Similarly, here image of 2 is 4, okay, we have defined the function g from y to z, okay, that is elements of y are assigned uniquely to the elements of z. That is, image of 2 is 4, image of 4 is 16, image of 6, 36, image of 8, 64, image of 10, 100. Okay, so here now let us define composition of two functions. For that, let f from x to y and g from y to z be two functions. Then composition of two functions f and g is the function, okay, composition of two functions is also a function, is the function. How to define? See, g composite f, okay, composition of functions g and f and g is g composite f from x to z, okay. Here f from x to y and g from y to z, composition of f and g is nothing but x to z, okay. So here x to z, okay, not x to y, x to z given by g composite f of x is equal to g of f of x, okay. First we will find f of x, then g of f of x, okay. G of f of x for all x belongs to x. All these x's are the elements of x, okay. It is the definition of composition of functions, two functions. Let f from x to y and g from y to z be two functions. Composition of two functions f and g is the function g composite f, okay. It is represented as g composite f from x to z given by g composite f of x is equal to g of f of x. See, when we are asked to find g of f of x, first of all we will find f of x, then we will find g of f of x. G of f of x for all x in x. So let us go through an example. Let f from set 1, 3, 4 to set 3, 4, 5 and g from set 3, 4, 5 to 6, 8, 10 be functions defined by f of 1 is equal to 3, f of 3 is equal to 4, f of 4 is equal to 5, g of, that is, see here, image of 1 is 3, image of 3 is 4, image of 4 is 5, and g of 3 is equal to 6, g of 4 is equal to 8, g of 5 is equal to 8. Okay, now we have to find the value of g composite f of 3. G composite f of 3. See, what is g composite f of x? That is equal to g of f of x, right? So we can write it as g of f of 3. Okay. So as I mentioned before, see, first of all, let us write the value of f of 3. Okay. That is g of, what is f of 3? That is image of 3. That is 4, right? F of 3 is 4. So g of 4. Now what is g of 4? Image of 4, g of 4 is nothing but 8. Okay. Therefore, g composite f of 3 is equal to 8. See the next question. Let f from n to n defined by f of x is equal to x plus 1, x belongs to n. And g of x, if g of x is equal to x minus 1 if x greater than 1, 1 if x is equal to 1, then find g composite f. Second question, check whether g composite f is an onto function. So here, first of all, let us find g composite f. G composite f of x is equal to g of f of x according to the definition. Okay. So here, that is g of, here it is given f of x is, f is defined by f of x is equal to x plus 1. So g of x plus 1. Now, what is g of x plus 1? Here g is, the function g is defined by g of x is equal to x minus 1 if x greater than 1. Okay. And see here, this function is defined g from n to n. Okay. G from n to n and f from n to n. Therefore, the function g composite f from n to n itself. Okay. And g of x plus 1, see, it is given g of x is equal to x minus 1 if x greater than 1. Okay. So here x greater than 1. Here x plus 1 is always greater than, right? Obviously it is greater than 1. Why? Because x is positive values. Because here the function from n to n, natural numbers to natural numbers. So this set containing only whole numbers, that is from only positive integers. Okay. So g of x plus 1 is nothing but it is greater than 1. Okay, x plus 1 is greater than 1. See, here it is given if x is greater than 1, g of x is equal to x minus 1. Okay, so it is x minus x plus 1 minus 1. Okay, if x is greater than 1, g of x is equal to x minus 1. So g of x plus 1 is x plus 1 minus 1. Okay, x plus 1 minus 1. That is nothing but x. And we know that the function g composite f from n to n. Okay, f from n to n and g from n to n. Therefore, g composite f is nothing but n to n. And here we have got g composite f of x is equal to x. Now, we have found the value of function g composite f is equal to, okay, x. Now next question is, check whether g composite f is an onto function. See, here we have got g composite f of x is equal to x itself, right? See, what about f of x is equal to x? Is it composition or not? Sorry, is it onto function or not? See, f of x is equal to x and f from n to n. Okay. So here two sets, okay, n to n, okay, function f from n to n. Our function is defined by f of x is equal to x. That means n to n means starting from 1, okay, 1, 2, 3, 3, 4, etc. Here also 1, 2, 3, 4, 5, etc. Okay, so here the image of 1 is 1, image of 2 is 2. Why? Because f of x is equal to x, right? So f of 1 is equal to 1, f of 2 is equal to 2, f of 3 is equal to 3. So here f of 4 is equal to 4. Therefore, here every elements of codomain has one pre-image. That means every element of codomain is the image of some elements of n, some elements of domain, right? Because here f of 1 is equal to 1. See here some 95. This has also pre-image 95 itself, right? Therefore, we say that f of x is equal to x is an onto function, because here every element of codomain is the image of some elements of the domain, right? Therefore, here f of x is equal to x is an onto function. Similarly, here this function g composite f of x is equal to x. So here g composite f is an onto function. G composite f is an onto function. Okay, this function is called, see, if f of x is equal to x means it is an identity function, right? So remember, an identity function is an onto function. Okay, so g composite f is an onto function. Now third example, if f from R to R is defined by f of x is equal to x square minus 3x plus 2, find f composite f of x and f composite f of 1. So first of all, let us find f composite f of x. So here function f is defined from R to R by f of x is equal to x square minus 3x plus 2. So f composite f from R to R itself, okay? Function f from R to R, therefore f composite f means, see, f from R to R and f from R to R. F composite f is nothing but R to R itself, okay? So now let us find what is f composite f of x. So f composite f of x is equal to f of x, that is equal to f of, now first of all let us write the expression of inside the bracket, that is f of x. So what is f of x? X square minus 3x plus 2. Okay. Now f of 3x, x square minus 3x plus 2. So here f of x is equal to x square minus 3x plus 2, right? Then what is f of x square minus 3x plus 2? So let us substitute this expression in place of x, right? So x square in place of x you should write, substitute x square minus 3x plus 2. So x square minus 3x plus 2 whole square minus 3 into, substitute x as x square minus 3x plus 2 plus 2. Now here, seeing both term, x square minus 3x plus 2 is common. Let us take it out. X square minus 3x plus 2 into, here remaining x square minus 3x plus 2 minus 3 plus this 2, okay? And here it will become x square minus 3x plus 2 into, here 2 minus 3 is minus 1. So x square minus 3x minus 1 plus 2. Now let us expand this one. X square into x square, x raised to 4. X square minus 3x minus 3x cube, x square into minus 1 minus x square. Minus 3x into x square minus 3x cube minus 3x into minus 3x plus 9x square minus 3x into minus 1 plus 3x, okay? And 2 into x square plus 2x square, 2 into minus 3x minus 6x, 2 into minus 1 minus 2, okay? Then plus these 2, okay? So here, see what are the terms cancelling? Here my x square is 2 minus x square plus 2x square minus 2 plus 2 cancelled. Okay, now let us write x raised to 4 minus 3x cube minus 3x cube, that is minus 6x cube, and minus x square plus 9x square is plus 8x square, plus 8x square plus 2x square is plus 10x square, and what are the terms? X minus 6x plus 3x minus 3x, that's all. So here f composite f of x is nothing but x raised to 4 minus 6x cube plus 10x square minus 3x. Now let us find f composite f of 1. F composite f of 1 is, substitute x is equal to 1. So 1 raised to 4 minus 6 into 1 cube plus 10 into 1 square minus 3 into 1. That is 1 minus 6 plus 10 minus 3. That is minus 5 plus 10, 5. 5 minus 3, 2. Okay, 10 minus 3 is 7. 7 minus 6, 1. 1 plus 1, 2. So f composite f of 1 is 2. Consider the function f of x is equal to 3x plus 4 divided by x minus 2, x not equal to 2. Find a function g of x on a suitable domain such that g composite f of x is equal to x, that is equal to f composite g of x. So here we have to find a domain, an element from the domain of the function g, that is g of x. Okay, we have to find g of x, that is an element from the codomain. Okay. So for that, here see, if the function is defined, f is defined here, f of x is equal to 3x plus 4 divided by x minus 2. Let us take an element from the codomain, that is let y is equal to, okay, y is equal to 3x plus 4 divided by x minus 2. Okay, let y is equal to 3x plus 4 divided by x minus 2. Now let us make it in the form of x is equal to in y terms. Okay, so let us simplify. Take this one here. So xy minus 2y is equal to 3x plus 4. See, here we have to make x terms in left side, that is x is equal to, right? So take all the x terms left side. So it will become xy minus 3x is equal to, and take all the y terms right side. So 4 plus 2y. Okay. And here x is common. Let us take it out. X into y minus 3 is equal to 4 plus 2y. That is x is equal to 4 plus 2y divided by y minus 3. Now here it is x is equal to 4 plus 2y y minus divided by y minus 3. And now let us take here, consider g of x is equal to 4 plus 2x divided by x minus 3. Now we have to check whether g composite f of x is equal to x or not. If it is x, now we can confirm g of x is equal to 4 plus 2x divided by x minus 3. Okay, now let us take. So for that, here let us find g composite f of x, that is g of f of x. Okay, that is g of f of x is 3x plus 4 divided by x minus 2. Okay, and here x not equal to 2. Okay, if x is equal to 2, it will not be defined. Okay, so x not equal to 2. Okay, so here now let us find g of 3x plus 4 divided by x minus 2. That is how to find. See, our g of x is this one, right? 4 plus 2x divided by x minus 3. So in place of x, we have to substitute this expression. Okay, that is equal to 4 plus 2 into, so in place of x, we should write 3x plus 4 divided by x minus 2. 3x plus 4 divided by x minus 2, because our g of x is this one. So g of this one is, in place of x, we should put 3x plus 4 by x minus 2 divided by, here x minus 3. What is x? X is this one. 3x plus 4 divided by x minus 2 minus 3. Now let us simplify this one. Take LCM. So it will become 4x minus 8, and multiply these two to each term inside the bracket, plus 6x plus 8 divided by, here also take LCM. So 3x plus 4 minus 3x plus plus 6, right? Okay. So that is equal to, see here, denominator of numerator x minus 2 is there. Here also denominator of denominator x minus 2, that is cancelled. Okay. So after that, see, it will become 10x minus 8 plus 8 cancelled, divided by plus 3x minus 3x cancelled, 4 plus 6 is 10, that is equal to x. Okay, similarly, you can find f composite g, that also you will get x. Therefore, we can write g of x is equal to 4 plus 2x divided by x minus 3. Okay, therefore our g of x is equal to 4 plus 2x divided by x minus 3. Now we are going to study inverse of a function. We have learned what is the function and types of function. So next we will study here inverse of a function. So here inverse of function, in this we will study how to check given function has inverse or it is invertible or not. So for that, let us take a function f from R to R. Let us define a function f from R to R defined by f of x is equal to 2x minus 3. Okay, and let us define another function g from R to R itself. Okay, R to R defined by g of x is equal to x minus 3, sorry, x plus 3 divided by 2. So here we have defined two functions f and g. F is defined by f of x is equal to 2x minus 3 and g is defined by g of x is equal to x plus 3 by 2. Okay, now here let us find g composite f and f composite g. So first of all, let us find f composite, g composite of f, that is g of f of x. Okay, that is equal to g of f of x is 2x minus 3. Okay, that is equal to, now g of x is this one. So what is g of 2x minus 3? Substitute in place of x, substitute 2x minus 3 in place of x, right? So 2x minus 3 plus 3 divided by 2, that is equal to minus 3 plus 3 cancelled. After that 2x by 2, that is equal to x. Okay, now let us find f composite g of x, that is f of g of x, right? That is equal to f of g of x is x plus 3 divided by 2, that is equal to, here f of x is 2x minus 3, so f of x plus 3 by 2 in place, substitute in place of x, x plus 3 by 2, okay, 2 into x plus 3 by 2 minus 3, that is equal to 2, 2 cancelled, so x plus 3 minus 3, 3 minus 3 cancelled, x. Okay, so here we have got g composite f of x is equal to x and f composite g of x is equal to x. That means, see, we have already know that if f of x is equal to x, such a function is called an identity function, right? So here we have got g composite f and f composite g are an identity function. Okay, g composite f is an identity function and f composite g is also an identity function. So here in this case we call this g as the inverse of a function f. Okay, see here we have got g composite f and f composite g are identity functions. Okay, so in this case we call this g as inverse of the function f and it is denoted as f inverse. Okay, so remember, see, when you are doing the problems or solving the problems, see, if you get this one, g composite f of x is equal to x, that means if g composite f is an identity function, then we can conclude that g is the inverse of the function f. Okay, and it is denoted by f inverse. So f inverse of x is equal to g of x. Okay, so next, And one more, let x is equal to set ABC, okay, ABC, and let y is equal to set PQR, and f from x to y defined by f of A is equal to P, f of B is equal to Q, f of C is equal to R. Okay, here, okay, let f is equal to f from x to y is an on-to and one-one function. Okay, one-one function given by f of A is equal to P, f of B is equal to Q, f of C is equal to R. So here we have, it is given the function f from x to y is an on-to and one-one function, and it is given by f of A is equal to P, f of B is equal to Q, f of C is equal to R. Then here we can show that there exists another function g from y to z, sorry, y to x, okay, another function y to x such that f composite g of x is equal to x and g composite f of x is equal to x. So you can prove it with an example. So here x is equal to two sets, x is equal to ABC, y is equal to PQR, and we have taken a function, an on-one and on-two function given by f of A is equal to P, f of B is equal to Q, f of C is equal to R. Then here we can show that there exists another function g from y to x such that f composite g of x is equal to x and g composite f of x is equal to x. That means f composite g and g composite f are identity functions. That means, see, we know that here we have already studied if f composite g and g composite f are identity function, then g is the inverse of the function f. F is invertible and its inverse is nothing but the function g, right? So here also note it down, if a function f is 1, 1 and onto, then the function f is invertible. Okay, remember, if a function f is 1, 1 and onto, then that function is invertible. That means this function has inverse function. Okay. Now how to define inverse of a function? A function f from x to y is said to be an invertible function there exists a function g from y to x such that our conditions f composite g of x is equal to I and g composite f of x is equal to I. Means f composite g and g composite f are identity functions. Okay, and see, in this case we can say given function is invertible, and see, this function g is the inverse of this function f. Okay, and it is denoted by f inverse. Now let us go through some examples. First example, f from set 1, 2, 3, 4 to set 5 defined by f is equal to 1, 5, 2, 5, 3, 5, 4, 5. Thus the function f invertible. So here, for to check the f is invertible or not, For that, first of all, let us check this given function is 1 1 or 1 1 and 1 2. Okay, if the function is 1 1 and 1 2, then we can confirm the given function is invertible, right? So here the given function is defined by 1 5 2 5 3 5 4 5. See, here only one element in codomain, it has pre-image, therefore it is 1 2. Okay, but here see this 5 has more than one pre-images, right? See, what is an 1 1 function? 1 1 function, that is distinct elements have distinct images, right? Distinct pre-images. So here that this 5 has more than one pre-images, therefore this function is not an 1 1 function. Okay, therefore this function is f is not invertible. Okay, that means this function f has no inverse function. Why? Because this function is not 1 1 function. Okay, since f is not 1 1. Consider f from set 1 to 3 to set ABC given by f of 1 is equal to A, f of 2 is equal to B and f of 3 is equal to C. Find f inverse and show that f inverse of inverse is equal to f. So here first of all let us write the function f defined by 1A, 2B, 3C. That is image of 1 is A, image of 2 is B, image of 3 is C. And clearly it is bijective function, that is 1 1 and 1 2 function, right? Why? Because here every distinct elements, distinct images have distinct pre-images, and every element of domain, codomain is the image of domain, right? So therefore it is 1 1 and 1 2 function, hence it is f is invertible. Okay, f is invertible. And now let us write f inverse. See how to write f inverse. See, just interchanging the first elements and the second elements, right? That is A1, B2, C3. It is f inverse. Now let us write f inverse of inverse. Inverse of f inverse. That is nothing but here interchanging the elements of f inverse. Okay. That is 1A, 2B, 3C. See, it is nothing but f. Therefore, f inverse of inverse is equal to f. Next example, let f from R to R be given by f of x is equal to 2x plus 1 divided by 3. Find f composite f and show that f is invertible. Here we have to show given function f is invertible. For that we have to check whether this function is 1 1 and 1 2. Okay, if 1 1 and 1 2, we can say the function is invertible. Before that we have to find f composite f of x, that is equal to f of x, that is equal to f of x is 2x plus 1 divided by 3. Now let us find f of 2x plus 1 divided by 3. f of x is this one. So replace x to 2x plus 1 by 3. That is equal to 2 into, in place of x you have to substitute this expression, 2x plus 1 by 3 plus 1 divided by 3. Simplify. Here 2 into 2x, that is 4x plus 2, and take LCM, plus 3 divided by 3 divided by 3. That is equal to 4x plus 5 divided by, this 3 will come to numerator, that is 9. Okay. So here we have got f composite f is 4x plus 5 divided by 9. Okay. Now let us check whether this function f is 1 1 and 1 2. First of all, for 1 1, okay, for 1 1 we will take x1 x2 belongs to R, okay, from here, such that f of x1 is equal to f of x2. In this way, we will check whether this function is 1, 1 and 1, 1, 1 or not. Okay. So here f of x1 is equal to f of x2. So what is f of x1? 2x1 plus 1 divided by 3, that is equal to 2x2 plus 1 divided by 3, that implies 3 cancelled. So 2x1 plus 1 is equal to 2x2 plus 1. So 1 also cancelled. This implies 2x1 is equal to 2x2. This implies 2 cancelled. So x1 is equal to x2. So here we have got f of x1 is equal to f of x2 implies x1 is equal to x2. So here according to the definition of 1, 1 function, here f is 1, 1. Okay, therefore f is 1, 1 function. And now let us check whether this function f is own to or not. Okay, so for that let us take an element from the codomain, that is y belongs to f of x, that is R. Okay, so y is equal to f of x. That implies, what is f of x? Y is equal to 2x plus 1 by 3. Okay, now here we have to make x left side and y terms in the right side. Okay, so like that we have to simplify. So 3y is equal to 2x plus 1. Take 2x left side, so minus 2x, or take 1 here. 3y minus 1 is equal to 2x, and take 2 here. So 3y minus 1 is equal to 2 is equal to x. That implies x is equal to 3y minus 1 by 2. See here, if you substitute any real values to y, you will get another real value, right? So it belongs to set of real numbers, because our function is from R to R, real numbers, set of real numbers to set of real numbers. So here if you substitute any values in y, so you will get another real value that belongs to R, right? Therefore, here we have got every element of codomain is the image of some element of the domain. Okay, every element of the codomain is the image of the some element of the codomain. That means every element has pre-images in R. Okay, therefore this function is own to. F is own to function. So f is 1, 1 and own to function, hence it is bijective. Therefore this function is invertible. Hence it is invertible. Hence f is invertible and it has inverse function. Look at next example. Let f of x is equal to x minus 1 by x minus 3, x not equal to 3, and g of x is equal to x minus 3 by x minus 1, x not equal to 1, be two real valued functions defined on R. So first question is, find f composite g of x, x not equal to 0. So here two functions are given and we have to find f composite g. F composite g of x is equal to f of g of x, that is equal to f of g of x is x minus 3 divided by x minus 1. Next we have to find f of x minus 3 by x minus 1. See how? Substitute, replace x to the expression x minus 3 by x minus 1. Okay, that is substitute x minus 3 by x minus 1 in place of this x, that is x minus 3 divided by x minus 1 minus 1. Here also x minus 3 divided by x minus 1 minus 3. Now let us simplify. Take LCM on numerator and denominator. X minus 1 into 1. See, x minus 3, and multiply this minus 2 each terms of the inside the bracket, that is x minus 3 minus x plus 1 divided by x minus 3. Here also take LCM, x minus 3, and multiply minus 2 each terms of inside the bracket. Minus 3 minus 3x plus 3, right? And the denominator of numerator and the denominator of denominator, x minus 1 is cancelled. Then here x minus x cancelled. So minus 3 plus 1 minus 2 divided by Minus 3 plus 3 cancelled. X minus 3x is minus 2x. That is equal to 1 by x. X not equal to 0. So here we have got f composite g of x is equal to 1 by x. X not equal to 0. If x is equal to 0, it will not be defined, right? So write 1 by x, x not equal to 0. Next we will find f inverse of x and g inverse of x. So first find f inverse of x. For that, here f of x is equal to x minus 1 by x minus 3 means it is an element from the codomain of the function f, right? So here let us take an element y from the codomain that is equal to f of x. Okay, let y is equal to f of x, that is equal to x minus 1 by x minus 3. Now that is y is equal to x minus 1 by x minus 3. Now let us simplify this one so that x will be in left side, x is equal to in y terms. Okay, right side it is in y terms. So simplify xy minus 3y is equal to x minus 1. That implies take all the x terms left side because we have to make x is equal to. Okay, x is equal to, so xy minus x, okay, taken this x left side, that is equal to 3y minus 1. This implies here in both terms x is common. Let us take it out. X into y minus 1 is equal to 3y minus 1. This implies x is equal to 3y minus 1 divided by y minus 1. See, our function is defined on R. It is mentioned here, that is function f from R to R, g from R to R. So if you substitute any values on y, you will get another real number that belongs to R, right? Therefore, x is equal to 3y minus 1 by y minus 1 belongs to R. Here, see, it is an element from the codomain, right? That is x minus 1 by x minus 3, and it is an element from the domain of the function f. Okay. Therefore, here f inverse of x, that is also an element from the f inverse of x is means element from the domain, right? Therefore, here we can write f inverse of x is equal to 3x minus 1 divided by x minus 1 because this element belongs to R. Okay. Therefore, f inverse of x is equal to 3x minus 1 by x minus 1. So, similarly, we can find g inverse of x. We have got f inverse of x is equal to 3x minus 1 divided by x minus 1. Now let us find g inverse of x. For that, see here also let us take an element from the codomain of the function g, okay, z. Z is equal to g of x, that is equal to x minus 3 by x minus 1. So now let us simplify this one so that x is equal to in z terms, okay. That is z is equal to x minus 3 by x minus 1. This implies zx minus z is equal to x minus 3. This implies take x terms left side. So zx minus x is equal to z minus 3. Okay. And here also x is common in both terms. Let us take it out. X z minus 1 is equal to z minus 3. That implies x is equal to z minus 3 by z minus 1. Z not equal to 1. Okay. See, here also we have got an element from the domain of the G. Okay. And it belongs, yes, we have to check it is whether it is in R or not. Okay. So here, see, our function is defined on R, right? That is G from R to R. Therefore, if you substitute any real values on Z, we will get another real value, right? Therefore, here we can say it belongs to R. Okay. Hence, it is an element of the domain of the function g, and g inverse x is also an element from the elements of the domain, right? Therefore, here also we can write g inverse of x is equal to x minus 3 divided by x minus 1, x not equal to 1. If x is equal to 1, it will not be defined. So, we should write x not equal to 1. So, g inverse of x is x minus 3 by x minus 1. X minus 3 by x minus 1, x not equal to 1. Here also x not equal to 1. Okay. Now let us find third one. See, third one, G composite f inverse x. Okay, that is inverse of G composite f. Now let us see how to find it. See, inverse of G composite f is nothing but f inverse composite G inverse of x. Okay, remember G composite f inverse or inverse of G composite f is f inverse. Okay, it is replacing. Okay, f inverse composite G inverse of x. Okay, the interchanging of the places. See here, G composite f inverse, that is equal to f inverse composite G inverse. Now f inverse G inverse of x, that is f inverse of G inverse of x is x minus 3 divided by x minus 1. Now let us find f inverse of x minus 3 by x minus 1. F inverse of x is this one. So here in place of x we should substitute this expression. Okay, we have to find the f inverse of this one. F inverse of x is this one. So substitute x to x minus 3, x minus 1. Okay, so f inverse of x minus 3 by x minus 1 is equal to here 3 into x minus 3 by x minus 1. Okay, replace x to x minus 3 by x minus 1 minus 1 divided by here also x is x minus 3 by x minus 1 minus 1. Now let us simplify. Okay, take LCM. So 3x minus 3x into 3x minus 3 into 3, that is 9, and here also multiply minus 2 each terms of the bracket. See here when you multiply x minus 1 into 1, x minus 1, so after multiplying, so here you have to multiply minus 2 each terms of inside the bracket, right? So that is minus x plus 1 divided by here x minus 3 minus x plus 1. And here also the denominator of numerator and denominator of denominator x minus 1 is cancelled. Okay, therefore it will become 3x minus x, 2x minus 8 divided by here minus 3 plus 1 minus 2, that is equal to minus 2. We can take minus 2 outside from the numerator to cancel the denominator. Minus 2 into 4 minus 2x, right? So 4 minus x. I have taken minus 2 outside, okay, to cancel this denominator. So minus, that is minus 2 cancelled, 4 minus x. So 4 minus x is G composite f inverse of x is 4 minus x. Next example, consider f from r plus 2 minus 5 to infinity given by f of x is equal to 9x square plus 6x minus 5. Show that f is invertible with f inverse of y is equal to root of y plus 6 minus 1 divided by 3. So here the given function is r plus 2 minus 5 to infinity. R plus means only positive real numbers, 2 minus 5 to infinity, and it is given by 9x square plus 6x minus 5. See, whenever you ask to find the f inverse, you just take an element from the codomain, that is y belongs to f of x, or y is equal to f of x, that is equal to 9x square plus 6x minus 5. Okay, after that you have to simplify so that x in left side and y terms in right side. Okay, so here 9x square plus 6x minus 5 is equal to y. Okay, so here all the x terms in left side and it is its degrees 2, right? So here we can write 9x square means 3x plus 3x and plus 1 whole square. So it will be 9x square plus 6x plus 1, right? So this can be written as, if we subtract minus 6 it will be this one, right? That is 9x square plus 2 into 3, that is 6x, plus 1 minus 6, it will be minus 5, right? So here this can be written as this one, 3x plus 1 whole square minus 6 is equal to y. This implies 3x plus 1 whole square is equal to y plus 6. This implies, take square root, okay? Square root on both sides. So 3x plus 1 is equal to square root of y plus 6. This implies 3x, take 1 right side. So because we have to make only x on left side, okay? So 3x is equal to y root of y plus 6 minus 1. This implies x is equal to square root of y plus 6 minus 1 divided by 3. Okay. Now here we have got an element from the domain of the function f. Okay. And here, see, this one belongs to r. Okay, r plus. And here, let us define another function g, okay, from minus ∞ to infinity to r plus. Okay. See, here also, if you substitute any real values, it will not be a real number, right? Because see, if you substitute y is equal to minus 7, for some values it will not be a real number. See, for y is equal to minus 7, you will get a square root of minus 1. It will be a complex number, right? Imaginary number. So here we can define a function g from minus 5 to infinity to r plus such that g of y is equal to square root of y plus 6 minus 1 divided by 3. See, from minus 5 to infinity, you will get a real number, right? Because see, if you substitute minus 5, it will be square root of 1, 1 minus 1, it is 0, okay? Or you can substitute minus 4, that is minus 4 plus 6, square root of 2, so it will be a real number, right? So it belongs to r plus. Okay, next we have to find, yes, we have to check whether this function 1, 1 and 2. Then only we can say this function f is invertible, okay, and with f inverse y is equal to this one, okay. So for that, let us find f composite g and g composite f, okay. See, our g function g is defined by root of y plus 6 minus 1 divided by 3. So if we get the f composite g and g composite f an identity function, then we can confirm f is invertible and it is the inverse of this function f, right? So let us find f inverse of, g composite f of x or g composite f of y, okay. G composite f of x is equal to g of f of x, that is equal to g of 9x square plus 6x minus 5, that is g of x. What is g of x? G of x is square root of x plus 6 minus 1 by 3. Okay, g of y is square root of y plus 6 minus 1 by 3. Therefore, g of x is square root of x plus 6 minus 1 by 3. So here in place of x, we have to substitute this expression, right? Because g of x is this one, okay. Therefore, square root of, in place of x, we have to substitute this one, that is 9x square plus 6x minus 5, okay, plus 6 minus 1 divided by 3. That is equal to, here square root of 9x square plus 6x plus 1 minus 1 divided by 3. See, here it is nothing but 3x plus 1 whole square, right? So its a square root, it will be 3x plus 1 itself. So divided by 3, so it is 3x divided by 3 is equal to x. Now here we have got g composite f of x is x itself. So g composite f is an identity function. Next, let us check whether f composite g is an identity function or not. So here f composite g of x is equal to f of g of x, that is f of g of x is square root of x plus 6 minus 1 divided by 3. So what is f of x? What f of x is this one. So here in place of x we should substitute this expression. Okay, that is 9 into its square. So 9 into square root of x plus 6 minus 1 by 3 whole square, okay, plus six into, here also in place of x we should substitute this expression, root x plus 6 minus 1 divided by 3. Don't be confused. Okay, substitute. Here in place of x we should substitute this expression. Okay, because our f of x is this one, so f of this one is substituting x to this expression. That is equal to, here 3 square, that is 9, so 9 cancelled. So a minus b whole square form, that is a square x plus 6 minus 2 into this one, okay, 2 root x plus 6 plus 1 plus here 6, 3 2s are 6, so 3 cancel, 2 root x plus 6 minus 2 minus 5. Okay, so it is equal to, here minus 2 root x plus 6, 2 root x plus 6 cancelled. So x plus 6 plus 1 minus 7, okay, minus 2 minus 5, 7. So 6 plus 1, 7, minus 7 plus 7 cancelled, remaining x itself. Okay, so here also we have got f composite g of x is equal to x. So what does it mean? See here, f composite g and g composite f are identity functions. Therefore, this function f is invertible and it has invertible, its inverse is the g. Okay, g is the inverse of this function f. Okay, so what is g? G is nothing but, that is g of y is equal to root of y plus 6 minus 1 divided by 3. It is g of y. Okay, so g of y is the inverse of the function f. That is g of y is the f inverse of y. Okay, so f inverse of y is nothing but g of y, right? Because here f composite g and g composite f are identity functions. Okay, therefore f is invertible and g is the inverse of the function f. Okay, g is the inverse of f. That is f inverse of y is equal to g of y. That is square root of y plus 6 minus 1 divided by 3.